So for the next item, this is quite easy. And if you're wondering, my name is Edward Ko, and I'll be giving this equation I have. It's still easy. The given will be y is equal to 4x squared plus 2x plus 1. Now, this given is already in standard form. Our goal is to find the vertex, vertex form, and other properties. While it is possible to find the vertex in standard form alone, finding the vertex form first would be, way easier. So to start off, we have to complete the square. To do that, we isolate the x terms by putting them in a parenthesis, leaving the constant behind. That would be 4x squared plus 2x, put them in a parenthesis, plus 1. Next, since x squared has a numerical not equal to positive 1, as you can see, we factor out the 4 from the terms inside the parenthesis. So, we end up getting 4 times x squared plus 1/2 x. How did we get 1/2 x? Well, as you can see, 2x, and then we divide that by 4. We take away the 4 from it. So, that would be 1/2, because 1/2 of 4 is 2. Next is to make the perfect square trinomial. We have to find the half of the middle term and multiply its value by itself. So half of 1/2. Half of 1/2 is 1/4. Then we multiply that 1/4 to itself, which gives us 1/16. So we write down 4 times x squared plus 1/2 x plus 1/16. And don't forget the parenthesis. But remember, we have to add 1/16 on the other side of the equation. But since we have to isolate the y term, we subtract 1/16 to the other side. Let's slow down for a bit. We have to multiply 1/16 by 4. Why, you say? Remember the 4 that we isolated from the x squared earlier? Yes, we have to multiply it to that. So, we subtract 4 times 1/16 at the end of the equation. So we get y is equal to 4 times x squared plus 1x plus 1/16, close parenthesis, plus 1 minus 4 times 1/16. We're almost there. All that is left is to express the perfect square trinomial into a square of a binomial. So after adding up all our like terms, we get y is equal to 4 times x plus 1/4, close parenthesis, to the power of 2 plus 3/4. And that is our vertex form. So keep in mind that this will be our vertex form. Y is equal to 4 times x plus 1/4, close parenthesis, to the power of 2 plus 3/4. Now we have the vertex form. We can simply find the vertex, also known as HK. And the vertex is located at -1/4 because it's here, x plus 1/4. It should turn to negative if you find the h. And 3/4 because of this coefficient right over here outside. So it's positive 3/4. To get to the other points of the graph, we construct a table of values with at least 2 points on the left and right of -1/4 for the x-axis. So, I came up with 4 values all in all. To the left, or the ones that are less than 1/4, is -3 and -2. Now, the ones that are greater than -1/4 is 0 and 1. Next is we have to input each number into the x variables in the equation. So I made this table right here where we can input our x values and we get our y values. So first up, we input -3. And using the vertex form, we replace x with -3. And with the power of calculator or mental math, our y or our output will be 31. So remember, for x, the input is -3, and the y, which is the output, is 31. Now we do -2. We input -2 and we get 13. Next, we input 0 and we get 1. Then we input 1, our output will be 7. And once we have all that, we plot each point into the Cartesian plane and connect them. They're magic. This is the power of parabola. But we're not done yet. We still have more, and I'm gonna pass this on into the next person. Alright, I'm back. And this is gonna be a little bit harder than the ones I introduced. This time, the given is y minus 4x squared is equal to 8x plus 1. Now, the equation is neither standard nor vertex form. But that's fine, I'm sure we can solve it. First, we have to turn it to a general form. To do that, we simply have to transfer ax squared to the other side of the equation. In other words, we have to isolate y. So, the negative 4x squared here is the ax, basically. We transpose that to the other side, making it y is equal to 4x squared plus 8x plus 1. The same process goes for the previous number that I just did. So, to start off, we have to complete the square. To do that, we isolate the x terms by putting them in the parentheses, leaving the constant behind. So, there you have it. 4x squared plus 8x, put them in a parenthesis, plus 1. Since x squared has a numerical not equal to positive 1, we factor out 4 from the terms inside the parenthesis. So, again, it becomes 4 times x squared plus 2x. Why 2x? Because 8 divided by 4 is 2. So, that's how you get 2x. Next is to make the perfect square trinomial. We have to find the half of the middle term and multiply its value by itself. So, same thing. So, half of 2 is 1. Then, multiply 1 to itself. That gives us 1. So, we write down 4 times x squared plus 2x plus 1 close parenthesis. Remember, we have to add 1 on the other side of the equation. But since we have to isolate the y term, we simply subtract 4 times 1. Why 4? The same thing I said. Remember the 4 that we isolated earlier from x squared? Yeah, we have to multiply that to the 1. So, we get y is equal to 4 times x squared plus 2x plus 1, close parenthesis, plus 1 minus 4 times 1. What's 4 times 1, by the way, guys? Easy, it's 4, duh. Anyways, we're almost there. All that is left is to express the perfect square trinomial into a square of binomial. So, after adding up all the like terms, we get y is equal to 4 times x plus 1 to the power of 2 minus 3. And that is our vertex form. I taught you how to find the vertex, and I'm gonna give you a few seconds to find the vertex just by looking at the vertex form. Okay, done. Anyways, the vertex is -1 and -3. While the vertex form, yeah, you already know. To graph this, we use the coordinates of the vertex, which is -1 and -3. This will serve as the point where the axis of symmetry lies. To get to the other points of the graph, we construct a table of values with at least 2 points on the left and right of -1. So here's the magic table again. The x is where we put our input, and the y is where we get our output. It's the same numbers. -3, -2, 0, and 1. Those are the values that I chose. You can choose anything as long as it's 2 values that are greater than -1 and 2 values that are lesser than -1. So, first, we input -3. What do we get? We get 13 as our output. Next, we input -2. We get 1. Then, we input 0. We get 1. Then, we input 1. We get 13. Now, you might be asking, yeah, how did you do that? Well, you see, the input, I don't know if you've noticed, but -3, right? -3 is the x. And if you want to find y, you can use the vertex form. So, y is equal to 4 times x plus 1 to the power of 2 minus 3. You replace that x with your input. So, since your input is -3, you write down, or you simply solve this in your calculator, y is equal to 4 times -3 plus 1 to the power of 2 minus 3. The same thing goes for all of your other inputs. You simply replace x with your input, then you solve for it, and that's how you get your y. So, there you have it. We plot each point into the plane, then connect them all, and there's your magical graph. The graph face down. I'll give this to the next person. Hey, I have returned Ray Edward here, and this is gonna be the hardest one yet. Kinda like the same process over and over, just bigger numbers. Without further ado, here's our given. Y minus 1/2 x squared is equal to x plus 5. Now this equation is neither standard or vertex form. Again, to make it into a vertex form, we need to find the general form. And to do that, we have to isolate y. Again, yeah, let's transfer -1/2 x squared to the other side. What do you get? Here's the general form. Y is equal to 1/2 x squared plus x plus 5. Okay, there you have the general form. Now, we can start looking for the vertex form. To start off, we have to complete the square. And, same thing, isolate the x terms, put them in a parenthesis, leaving the constant behind. So to do that, parenthesis 1/2 x squared plus x, close parenthesis, plus 5. Since x squared has a numerical that is not equal to +1, we factor out 1/2 from the terms inside the parenthesis. So we end up 1/2 times x squared plus 2x. So you might be asking, why? How did you get 2x? Well, you see, that x over there, it has a 1x. We don't have to write 1x because that's just the same as x. So pretend there's an invisible 1 there. You divide 1/2 from 1. 1/2 divided by 1. What do you get? 2x. That's how you get 1/2 times x squared plus 2x. Next is to find the perfect square trinomial. We have to find the half of this middle term and multiply its value by itself. So half of 2 is 1. Then we multiply 1 to itself, that gives us 1. So we write down 1/2 times x squared plus 2x plus 1. But remember, we have to add 1 to the other side of the equation again. Then we have to isolate y again. So that means we have to subtract 1/2. Remember the 1/2 that you removed from x squared? Yes, multiply that to the 1. So we get y is equal to 1/2 times x squared plus 2x plus 1, close parenthesis, plus 5 minus 1/2. Anyways, we're almost there. All that is left is to express the perfect square trinomial into a square of a binomial. So after adding up all the like terms, we get y is equal to 1/2 times x plus 1 to the power of 2 plus 9 over 2. That's our vertex form. Once you find the vertex form, you are able to find the vertex, which is -1 and 9 over 2. To graph this, we use the coordinates of the vertex, which is -1 and 9 over 2. This will serve as our point of axis of symmetry. To get the other points of the graph, we construct a table, magic table again. We find at least 2 points that are less than and another 2 points that are greater than -1. So, what's greater than -1? Well, 0 and 1. What's less than -1? -3 and -2. Next is to input each number into the x variables. We input -3. Now I want you to think. Vertex form. Let's use the vertex form to solve for the output. So remember the vertex form. Y is equal to 1/2 times x plus 1 to the power of 2 plus 9 over 2. Replace that x with your input, which is -3. And if you solve for that with your calculator, your output will be 6.5. If you replace x with -2, your output will be 5. If you replace x with 0, your output will be 5. If you replace x with 1, your output will be 6.5. Plot each point into the plane, and then voila voila, magic, connect them all, and there you have your parabola. Now I will pass this on into the last person. Hope you've enjoyed. I'm done my part, and bye bye.